Alright, I was saying in the last video, and I know it's going to get cut off because it was a little bit too long. So we were talking about the horizontal translation. And the horizontal translation, we see that we have y equals x minus the k squared. And it's very important that this reads as minus the k squared, because here for comparable y values we must use an x that has k added to it when it's minus, but only when it's minus. So now what I want to talk about is what happens when it's y equals x plus k, and that's what you're seeing here. So here's our comparable, right? Our 0, 1, 2, 1, 2s, and 3s, positives and negatives, and here's our comparable, or our original y values. We're not messing with the y's when we're doing a horizontal translation, we're messing with the x's. So here you'll see that 0 would give us 0, but it's a -3 that gives us 0. It was a 1 that gave us 1, but now it's -2, 1 minus 3. And that's because we need to be able to read this as y is equal to x minus a negative k quantity squared. And it's only when we do that that we know what value is added to or subtracted from our x. So this is what gets added to x's. For the comparable, and I'm just going to abbreviate that, comp y values. So here, when I'm looking at an original x value of 2, I'm going to add to that a -3, and that's going to give me a -1 for the value that originally would have given me a 4. So the 2 would have originally given me a 4. Now my x value that gives me a 4 is a -1, and that's what you see right here. So that's how we're going to be doing horizontal ones. Those are really, really tweaky for our mind, but once we kind of get the hang of it, it's easier to deal with. So now we're going to go and we're going to take a graph through all of its translations based upon this idea. So first of all, I'm going to start here with my function. I have my m of x is equal to 2 times x minus 1 quantity squared plus 3. And I'm going to go through these translations that I've talked to you about. So the first translation is going to start based upon my original function values. So my original function values would have been for, I'm going to go with the -2 and -1, a 0, a 1, a 2, and I'm just going to do a 3 as well so you can kind of see things. And you'll see why I do the 3 in just a moment. So my original values would have been a 4, a 1, a 0, a 1, a 4, and a 9. Now the way I've listed them here is a little bit differently than the ones that I had listed before because I've gone in numeric order for my x's so that you can also see how my x's change. Now my first translation is going to be a vertical translation. I'm going to do the function g of x. And g of x is just this part right in here. And I'm going to translate it to the right by 1. So for my original values, I would have 1 greater than each of these x's. So this time I've written the 1 greater just a little bit differently. And what I've done is I've basically moved it down. So here's my y values moved down to show you that they're the comparable x values. So instead of rewriting the x's, right, the x's being here to an x prime, what I've done is I've moved the y values down by that 1. So I've added 1 to each of these values. So for a -2, then I'm having my comparable y value at a -1. For a -2, my comparable y value is at 1, and so on and so is at 0, and so on and so forth. So these, there's nothing here, and then we see the original values, 4, 1, 0, 1, 4. And here you see the 9 is slid off, and that's why I actually put this one in here, so that we could focus our attention back to same 5 values I have been using originally. So that's how I've expressed, just in a little bit of a different way from how I was expressing that in this particular table here, the x versus the x prime. I've done it by a shift downward of these y values. So now going back here, so you can kind of understand the flow here. So now that's g of x. Now for h of x, I'm going to take what I already have, the vertical translation, and I'm going to stretch it by 2. Well, stretching translation doesn't affect x values, right? So it affects y values. So all my y values from these translated values for the x's are just going to multiply by 2. So here we have all these particular values multiplied by 2 all the way through. And then the last thing I'm going to do is I'm going to do my finished function. Now this finished function is going to take the x function, or the h of x function, which is this portion right here, and it's going to add 3 to it. So what's going to change are my y values again. So I'm going to add 3 to 8, 2 to 3 to 2, 0 to 3, 2 plus 3, 8 plus 3, and we see our values again. So here in this set, what I've shown you is the same way of looking at the translations that I did before. So x's originally are a -2, a negative 1, a 0, a 1, and a 2. Now they have gone to a -1, a 0, a 1, a 2, and a 3. So that's where these shifts are. See, these are the x values that I'm using, and they're shifted down here. And you see those same values here that you're seeing here. And these are actually the values of x that are going in. So that's that kind of relationship. Now that's really, really tricky to see and to get a grasp on. But one of the two ways hopefully is going to kind of start making sense to you. So one of the ways that I can show you this particular set of translations is to kind of move this through the coordinate system. So if I start here with the axis system, I have a really hard time drawing straight lines on this. I have to really focus to try to get this to happen. So what I'm going to start off with is I'm going to start off with just the traditional function, the y equals x squared function. So I've got my 0, 0, I've got my 1, 1, negative 1, 1, my 2, and then let's see, that's 2, 3, 4, and my negative 2, and my 4, and then I have the 3, and I have a 9, so that's 5, 6, 7, 8, 9 there. And I didn't have the comparable negative 1, but you would know that that would be the same thing. So there we go with our parabola. Something like that. Sorry, that's not a very beautiful parabola, but you'll have to bear with me. And then what I do is I'm going to translate this. So now for x minus 1, what I'm doing is I'm going to shift it down and I'm going to do the negative 1. So x is equal to negative 1 and y is equal to the comparable value there. So when this is a negative 1, this is going to be equal to negative 1 is going to be equal to the 4, negative 4, positive 4. And then when we have the 0, it's going to be equal to our 1. And then when it's equal to 1, it's going to be our 0. And when it's equal to our 2, it's going to be back and equal to 1 again. And then when it's equal to 4, no, when it's equal to 2, it's back to our 1, and then when it's equal to 3, it's going to be back up to 4. And now you can see why I extended that off on the negative side, or on the 3 side on this one, on the positive side. And there we go. So there's that same parabola, and you see it's just shifted that way 1 unit. But this goes there, that went 1 unit that way, that one went 1 unit that way, this went 1 unit that way, that went 1 unit that way, and this one went 1 unit that way. So all of the points got shifted one place to the right, but just the x portion of them, the y's, stayed exactly the same. Now the next one that we're doing is the translation that takes us to the stretching. So now all of these y values are just going to get stretched up. So 0 times anything is still 0, right? So that one's going to stay the same. And then this one is going to get multiplied by 2. So all these values get multiplied by 2. So 1 times 2 gives us 2. And then 4 times 2 gives us 8. So this one gets stretched up to, should be to there. Let's see.